Okay, so let me tell, let me ask you, if A and A into B is there, and you'll be getting a number n here after this multiplication. If A is even and B is even, what will be the like even and odd, even or odd? You have to tell whether the n is even or odd. So n will be what? Will it be even or odd? Tell me, anyone?
Even.
Even. And if A is even, B is odd, then
नहीं आज से ना तो ये
yeah.
फॉर्मूला बनाना चाहिए
Shruti, अपना microphone off करो. Either you reply me or
Sir, it will be even.
it will be even. Or if it is, if both will be odd, then
Sir, odd.
it will be a odd number. So next thing is, if I'm adding two numbers, A plus B, and if both numbers are even, and we are getting n after this addition, the nature of n will it be odd or even?
Even.
Even. If one is even and one is odd, then
Odd. Odd.
odd. And if both are odd, then
Even.
so it is very like you can just think and tell. And so I'm not doing extra effort to elaborate these points. Just you need to know that sometimes you will also get questions based on this concept. Okay. So now they will be having more terms like one even and then odd and then one even and then odd and it's get multiplied by a even number, and they will ask if this n is there, what will be the nature of this n. So you can just think like even plus even will be a even number, even plus odd will be a odd number, odd plus even will be a odd number, and this will be an even number, then odd plus even will be an odd number. So nature of n will be an odd number. So you will have multiple terms, not just these two terms to tell that whether the value of n is even or odd. They can have more.
Excuse me, sir.
Yes, tell me.
सर आपने ऑड प्लस ऑड इवन लिखा है तो अगर 5 + 8 करेंगे तो 13 आएगा तो वो तो ऑड ही हुआ ना.
हाँ, तो ऑड प्लस ऑड लिखा है ना, यहाँ पे 5 जो है ये ऑड है, 8 ऑड नहीं है
अच्छा.
ना, ये तो ऑड आएगा ना, ये तो ऑलरेडी हमें बताया है. ठीक है,
ठीक है.
तो मल्टीपल टर्म रहेगा. You can be also like sometimes they can also ask in term of division, like if a odd number gets divided by an odd number, and let's say it get divided like O1 and O2, and in all these cases there is no remainder. There is no remainder. So odd divided by odd. So the value of quotient, ये क्या होगा? Quotient की value जो होगी वो odd होगी even होगी? Odd divided by odd.
Odd.
Yes, it will always be odd. And even divided by odd. What will be the quotient here?
It will be even.
It will be even. You could have just, you can check in reverse order, like odd into even can give you even, but odd into odd will not give you even. So it will not give you, that's why it will be even. So this is how you can check even and odd numbers. Okay. So you can get questions based on these concepts in your exams. And they will just write down multiple operations, and then they will ask like they can write down the odd number divided by odd number plus an even number divided by odd number, and then you have an odd number like odd into even number, and multiple terms they can give you, and then finally say the value n that you will get. You know, n will be an even number or odd number. So by this way, they can create questions. Now, we'll be going for unit digit, like what will be the unit digit. So before going to that unit digit part, just tell me like if a number, single digit number like 5 plus 8, if we are adding this, the unit digit will be what? The unit digit of summation will be, tell
Odd.
me. No, not odd. I'm just asking what will be the unit digit. Now it will
1.
be, I am asking the unit digit here, 3. So it will be 3. And if I'll add 15 plus 18, then
Also 3.
still it will be 3. And if I'll add like 2, 5 plus 2, 9, 8, now it will be 3 only. So the again, I'll also write it. If 8, 5 and not 5, let's say I'm asking 6 into 8. What will be the unit digit here?
2. 8.
8.
8.
It will be 48. So unit digit is 8. So
Eight.
if 16 into 18 is there, then
Also 3.
then also
8.
it will be 8. So unit digit will be 8 only. And if 2, 9, 6 into 3, 5, 8, if this multiplication is there, then unit digit will be, जल्दी बताओ.
Okay.
8.
So it will be
It will be 8 only. So here we are checking it and then realizing that the unit digit will always depends on the unit digit of the numbers that has been used to multiply or add. So this you can prove it like if a number is 16 plus 18, you can break it 10 plus 6 and 10 plus 8. So if we multiply these two terms, 10 will be multiplied by 10, which will have a 0. Then 10 will be multiplied by 8, it will again have a 0. 6 will be multiplied by 10, this will have a 0 again. So all these three part of the multiplication will not give you unit digit. It will give you unit digit as 0 only. And the last multiplication which is there, 6 into 8, basically this multiplication will give you the unit digit of multiplication. Unit digit of multiplication. So if you want to know the unit digit of any multiplication, you can include the other digits of the numbers, and you can just take the unit digits and you can calculate them to find the unit digit of the final multiplication. So that's why if I write it like 2 into 5 into 3 to 8, not 5, 6, 2, 2193. So unit digit of these multiplication, unit digit of this multiplication will be just 6 into 2, 12, and this 2 into 3, 6. So the unit digit will be 6 only. So are you getting my point? Is everyone getting my point? Tell me fast.
Yes,
The
sir.
unit digit we will get unit digit by the operations of unit digits only. Similarly, it will be true for 2 digits, 3 digits, 4 digits also. But as far as the question is concerned, they will ask for the last 2 digits only. So if there are 2 addition, 12 plus 16, the last 2 digit will be what? 28. Okay. And if I am adding 5, 1, 2 plus 6, 1, 6, this again will give you the last 2 digit as 28. Similarly, and again, if I'll multiply, like, let's say I'm multiplying 15 into 11. The last 2 digit will be, क्या होगा यहाँ पे? 65. So if I'm getting 65 here, so any two numbers which will have the last 2 digit as 15 and 11, if they get multiplied, will always give you the last 2 digit at 65 only. So like if I'm writing 515 into 711, this multiplication will also give you the last 2 digit as 65 only. So do I need to prove it like the previously, like the previous example? So you can prove it like 515 can be written as 500 plus 15 and 700 plus 11. So if I'll multiply 500 into 700, 500 into 700, whose microphone is on? Madan, just Madan, you can mute yourself. Okay, I did mute you. Okay. So 500 into 700, if 500 gets multiplied by 700, 500 gets multiplied by 11, this will again give you the last 2 digit as 0. 15 into 700, this multiplication will give you the last 2 digit as 20 only. And until these numbers, the last 2 digit is 00 only. So the last 2 digit of the multiplication will be getting by multiplying 15 into 11, which is 165, and this 65 will be the last 2 digit of multiplication. So is it clear now? It can have multiple numbers multiplied together, like 215 into 311 into 293 into 415, 415. So you can do it like, you can just multiply 15 into 11, it will get 65, and ignore the one part, 65 into 93, then whatever you'll get here, the last 2 digit, and that into 15. So this is how you can get the last 2 digit of this multiplication. So you don't have to use the calculator to calculate the last 2 digit. You can easily get that. So this particular concept, we use it as a core of framing another kind of question. Like if I'll say there is a multiplication 315 into 411, and if it's get divided by 100, what will be the remainder? What will be the remainder? So if we divide any number by 100, the last 2 digit will be the remainder of that digit. So like if we divide 1528 by 100, so how do you get 100? This will be 52 and 8, then 5 will be getting 500. The remainder is 28 only. So this last 2 digit is the remainder when any number's last 2 digit will be the remainder if the number gets divided by 100. So if there are multiple multiplication here, you can just find the last 2 digit and tell that what will be the remainder when it's get divided by 100. So is it okay for everyone? So now you know that we just need to take the concerned digit and find out the final digit of the same number or same multiplication or the multiplication. So let's say if a number is like 12 to the power 28 is there. And if somebody asks you what will be the last digit of this power, so what will be the last digit of the power? So similarly, you can have any question like 15 to the power 23, 16 to the power 41, 18 to the power 29. I can ask you the last digit of this number, whatever the number you'll get after multiplying 29 times 18. So in all these questions, what you actually see is this is nothing but multiplying 12 into 12 into 12 into 28 times. So you don't have to keep this one in your consideration. You just need to multiply. It will like the last digit will be the same if we are multiplying 2 into 2 into 2 for 28 times. So basically this and this, for both of the equations, the last digit or the unit digit will be same. We have already proved that. So now for getting the power, unit digits of power, you can check that if 2 gets multiplied one time, like just 2 is there, the unit digit is 2. And if 2 gets multiplied 2 times, that means 2 into 2, the unit digit is 4. If 2 gets multiplied 3 times, the unit digit is 8. And if the 2 gets multiplied 4 times, the unit digit we get is 16. So we'll ignore this one here. I'm just concerned with the unit digit. If 2 gets multiplied 5 times, then again I'll start getting the 2 here. And 2 to the power 6, then 4, 2 to the power 7, then in this case we'll have 8, 2 to the power 8, I'll again have 6. So what do you see here? You see that there is a cyclicity. There is a cyclicity of unit digit. So this is what we call it, cyclicity of powers. Cyclicity of unit digit for powers. So for 2, the cyclicity is 4. That means every fourth power of the 2 will give you 6. So the question was, what will be the unit digit of 12 to the power 28? So now what I know is the unit digit is 2 here. So I can ignore this one. And the power is divided by 4. 28 divided by 4, it will divide the 28. So that means that at 28th power, the unit digit will be 6 only. Is it clear to all of you? If it was 29, 12 to the power 29, you would have seen that 28th power will be 6, then 29th power will be 2 again. If somebody would have asked that 512 to the power 31, what will be the unit digit here? So I would have said that I'll ignore this 51. I'll take 2 to the power 28. The last number which is near to 31, which gets divided by 4, is 28 only. Then it gets divided by 2, then 2, then 2, like 3 times more. This is 2 to the power 31. So if this gets divided by, if this gets multiplied, you'll be getting 6. Then after 29th power, this is the 29th power, this is the 30th power, this is the 31st power. So after 6, you'll get again 2, then 4, then 8. So you can just count the how many powers ahead than 28, and we can move with this cyclicity. So like we have 2 here, all the digits that we have in our decimal system, how many digits do we have in our decimal system? 10. So I did not wait for your answer. I just told you. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So like 2, we will have a cyclicity of all these digits because any number in decimal system will be finished with any of these digits only. So if any number has 0 at its end, it will always give you 0. Any power of 0 will give you 0. Same stands for 1. Any power of 1, like 21 to the power 23, it will 33, it will be 1 only. So 1 always gets multiplied by 1 to give you 1 only. I have already calculated the cyclicity of 2, which was 2, 4, 6, 2, 4, 8, 6, and 2. This is cyclicity of 4. For 3, what will it be? Tell me. Anyone please tell. The 3 to the power 1, it will be 3 only. 3 to the power 2, what we will get here? 9. Then what we'll get again? 7. Then what we'll get again? After the fourth power? 1. So after that, we'll again get 3, then again 9, then again 7, then again 1. So this is how we get the cyclicity. So cyclicity of 3 also is 4, which is 3971. If 4 is there at the end of any number, then the second power, 4 to the power 1 will be 4, 4 to the power 2 will be 6, the unit digit of 4 to the power 2 will be 6. Then again, you'll be getting again 4, then 6, then 4, then 6. So the cyclicity of 4 would be 2 only. If 5 is there, you'll always get 5. If 6 is there, you'll always get 6. If 7 is there, then 7 to the power 2, kya hoga? What will be the unit digit of 7 to the power 2?
9.
9, then 7 to the power 3. 7 to the power 3 कितना होगा? 3. 7 to the power 4 कितना होगा? 1. So we are getting the cyclicity of 4 only. 7, 9, 3, 1. So this is the cyclicity of 7. What will happen in case of 8? The second power of 8 will give you what? 4. Then third power of 8 will give you 2. Then fourth power of 8 will give you 6. Then fifth power of 8 will give you 8 again. So you will be getting in similar order 8, 4, 2, 6, 8, 4, 3, 6. And the cyclicity of unit digit to the power of 8 is 4, and it is 8, 4, 2, 6. And cyclicity of 9 for the power of 9, but the second power of 9 will give you what? 1. Then third power will give you again 9 and 1. So cyclicity is 1 here. So with all these 10 digits, now we can tell any question like this, like if I'm saying 317 to the power 21, what will be the unit digit here? What will be the unit digit of this multiplication?
1.
1. How? Not 1. नहीं, गलत हो गया.
It's 7, sir.
It's 7 again. The 20th power will give you 1 because the cyclicity is 4. So 20 gets divided by 4. So 20th power of this will give you 1. And 21st power will give you 7 again. So the answer, yes. So is it clear to all of you? Everyone?
Yes, sir.
Very good. So now we'll be talking about last 2 digits also, but probably not like you might not get such question based on last 2 digits. but still nobody can say what will happen in your exam. So let me talk about the last two digits also. So we have already explained the part that if two numbers gets multiplied, and if you are trying to find out last two digits of that multiplication, you can ignore the other digits which are not the last two digits. Like you can just multiply the last two digits to get the last two digits of the multiplication. This I have already explained. Now the second part is this is also important for other questions also. Let's write all the squares of numbers from 1 to 25. So any one of you can help me in that. I'll be writing the square of 1, 2, 3, 4, 5, 6. You can just tell me the value. So the square of 1 will be still square of 1 only, and I'll be writing in with writing two digits here because that will help me in finding out the last two digits of multiplication ahead. The square of 2 will be
04.
04. The square of 3 will be
09.
09.
09. 4,
16.
5 square
25.
25. 6 square
36.
7 square
49.
49. 8 square
64.
64.
9 square 81. 100 square 20. I'm just writing the last two digits. Also, let me write the number also because till 25, if you are remembering it. So the square of 11 will give you 121. Square of 12 will give you what?
144.
4. Square of 13 will give you
169.
Very good.
196.
196. इसका बताओ
222.
425.
17 कितना होगा 289. 18 का स्क्वायर 326. 19 का स्क्वायर ये बताओ
361.
So 324 and 361.
324, sorry, and 361. The square of 20,
400.
400. 21, 441. 22,
484.
484. 23 square
529.
529. 24 square
576.
576. And 25 square would be 620. 620. So now you know two things here. Squares of all the numbers from 1 to 25, the value of squares, and also the last two digits of all the squares from 1 to 25. Now with this table, why I did such effort to make this table, we are having two important revelation here, that if we'll difference, find the consecutive difference. Let me ask, let me write the square of 0 also. So the difference here is, the consecutive difference is 1. Here you have the difference 1 plus 2, which is 3. Here the difference you have 2 plus 3, which is 5. Are you getting this pattern? The difference between the square of 3 and 4 is just the addition of 3 and 4 only. Here you have 4 plus 5, 9. Here you have what? 5 plus 6. So are you getting this point? Like everyone is observing it?
Yes.
So all the squares, now all the two consecutive squares are differentiated from each other in this manner only. And this is not a very great revelation that I am doing here. You can just uh, feel it by algebra only. Let's say if I'm checking 7 square minus 6 square, if I'm doing it like 7 square minus 6 square. So the algebraic expression for a square minus b square is what? 7 plus 6 and 7 minus 6. So that is 7 plus 6 and 7 minus 6. And you know this value is 1 only, but the difference is just the summation of these two numbers. Okay. So there is no big thing which I am mentioning here, but of course it helps. So it helps in what way? Like all of a sudden someone asked me to calculate the square of 41. So without multiplying, I can just write the square of 40 as 1600. And now I know the difference between 40 square and 41 square will be 81 only, which is 40 plus 41. And then I can add these two, 1681. I can write it 1681. Is it okay? Are you seeing this? Hello, everyone.
Yes.
Hello. So it's like very easy to calculate the squares, which is near to any zero.
So
Like,
can you give one more example?
of course, let's say I want to know the square of 49. So now I know the square of 50 is what? 2500. And difference between 49 square and 50 square would be what? 49 plus 50, which is 99. So I just subtract 99 plus from 2500 and I'll get what? 2401. Is it okay?
Yes, sir.
Now it's clear. It's clear to everyone. Like it helps in finding the square.
Excuse me, sir.
Yes, tell me.
सर ये 49 वाला फिर से रिपीट करवा दीजिए.
मैंने देखा कि 50 का स्क्वायर इज इजी इनफ टू कैलकुलेट. So I calculated the square of 50, which is 2500. यहाँ तक दिक्कत नहीं है?
Yes, sir.
And 49 के स्क्वायर एंड 50 के स्क्वायर का जो डिफरेंस होगा वो क्या होगा? 49 plus 50, which is 99. So if I'll subtract 99 plus from 2500, I'll get 2401, which will be the square of 49 square. Now clear? Is it clear to you?
Yes, sir.
Okay. So the first thing we are clear now. Now the second lesson that I'll be telling you is give me any other number other than 25. Other than these 25.
72.
How much? 72.
Yes.
72. And let's say I want to know what will be the last two digits of 72. I'm not concerned about the square of 72. Otherwise, you could have tell ki sir 70 ka square nikalo, then you keep on adding the numbers and you can get 72. But no, I just want to know the last two digits of 72, square of 72. And what I'll do here is I'll break the 72 into two parts. One is 50 minus plus 22. And I'll try to find the square by the algebraic expression, which is 50 square plus 2 into 50 into 22 plus 22 square. So the 72 square, I can get the square of 72 by adding these three terms. And what I know is this 50 square has last two digit as 00. Now, this multiplication will also have last two digit as 00 because 2 into 50 is there. And the last two digit of 22 square that I have already calculated, which was what? कितना था ऊपर? 84. The last two digit of 22 square is 84. So now I know after adding these three terms, the last two digit that I'll get is 84 only. Is it clear to everyone? Hello. Is it clear to everyone? Hello.
Yes, sir.
Yes, sir.
So with this example, or we can take other examples. Of course, I'll also take other examples. But the point or the lesson or the concept that I'm talking here is that every square, the last two digit of every square, last two digit of every square, digits of every square will come from the squares of 1 to 25. So, the two digits that we have got here in all these squares, the two digits that we have got here in all these squares, like 8 square, 7 square, 6 square, 15 square, 14 square. So all the two digits here that we have got, these are the only two digits we will be getting if we square any of the number ahead. So let's take another number. If you have any confusion or if you want to check it, how it is possible, let's take another number. Any other number, can you tell me? Other than 72, if you have doubt, any kind of doubt on this concept, and
93.
I'll also tell how we are getting it. So for 93, to calculate the square of 93, I will break this square into two terms. 100 minus 7. 100 minus 7. So the idea is here I'll take either 50 or 100, so that the plus or minus, you could have said, sir, I would have taken 50 plus 43 also. So why I'm not taking is because this term is 43. So I need to keep this term below 25 only. And with this number, we will take either I'll take 100 or I'll take 50 to subtract or add. So to calculate the square of 93, I'll break this into 100 minus 7 the whole square. And then I'll expand it like 100 square minus 2 into 100 into 7 and into, sorry, not into, plus 7 square. So like in the previous case, the last two digit here is 0 only. The last two digit here is 00 only. So the last two digit after this subtraction will be 00 only. So the last two digit of this square, 93 square, you'll be getting from 7 square only, which is 14. So the last two digit of 93 square will be equal to the last two digit of 7 square, which is 49. Okay, is it okay to everyone? So
Yes, sir.
now we can tell for any number what will be the last two digit of that square. So let's say all of a sudden somebody asked you 383 the square of 383. So what will be the last two digits of this square? Tell me. So this number will be breaked in what format? Can anybody tell me? It will be breaked in 400 minus 17. So this the last two digits of this square will be equal to last digit of 17 only, and which was 89. So is it clear to everyone?
Yes.
Yes, sir.
Okay. So this also helps in such type of question where some square or somebody tell you that find the root of the number. So if a number is like this, 2, 5, 6, 7, 8, and they will ask you like three such number will be given, and they can ask you four such number will be given, and they can ask you which square root will be an integer number. So now you know that there is no 78 in these all these numbers, like in any of these squares there is no 78. So this entire number cannot have a integer root. So many of the time you can be asked, or you may be asked such questions which are based on this concept that the last two digits of the any number will be coming from these 25 last digits only. Okay. So you will not get any other last two digits than these 25 last two digits. Is it clear to everyone? Tell me
So please explain one more time.
which part.
This is one. This is square root 1.
Square root ये वाला last question. Hello.
जी sir.
Last question ना. तो मेरा point ये था, I was just explaining that if there are four numbers written and you need to find that which of these numbers have integer square root. So rather than calculating the square root, we can also identify that any such number whose last two digits are not from any of these 25 will automatically not give any integer roots. Okay. So although it's not guaranteed that if a number will have 64 in the last two digits, will always lead to a perfect root. ऐसा नहीं होगा. But ये है कि यहाँ पे हम we can check. But this we don't need to check. So any number which doesn't have any of these 25 last two digits, you don't have to check that whether it will have a perfect root or not. Okay.